Hi, welcome to Starbucks. What can we get started for you today? I'm bouncing back to net because it seems like, yeah, people were getting hung up on it. So net is an overall change. Okay, net is about the overall change in temperature of the house, right? Um, if it starts at 72 and finishes, say, at 74, okay, this is the net. All right, that change is the net change, the overall change. If it starts at 72, ends at 74, then its net change is only 2 degrees Fahrenheit. If a house starts at 72, goes up to 1 trillion degrees, and then comes back down to 72, and the net is 0. And this temperature here, the very last temperature, remember, is the final cooling temperature, TCF. All right, and the very first temperature is the very first heating temperature, THI. So it's TCF minus THI. Snag-a-lag minus 72.
Well, I did it again.
Net change for the small home of 1 degree Fahrenheit. For the large home, net temperature change of 2. Goals. What are your goals, man? You're reaching your goals. You're reaching for the stars. What climate did you choose? I don't know. Let's pretend we're a hot climate first. So hot climate people are trying to, what are you trying to do during heating? Whenever your house is being heated up in a hot climate, if you're in a desert and you're under the scorching hot sun, you're trying to minimize your heating temperature change. If you're in a hot climate and this is what your temperature does once it's being subjected to heat, if it shoots up, okay, to 200, degrees, that's not good. You're going to die. You want the opposite of that. Okay. You want to minimize your heating temperature change. So if you're starting at 72, all right, ideally, here's what your temperature should look like throughout heating. All right. It stays flat line. So it starts 72 and ends at 72, and that's a heating temperature change of 0. That's ideal. Okay, so you're trying to minimize heating temperature change. All right. Cooling. Whatever heat that a hot climate home gains needs to be lost. So you're trying to maximize cooling temperature change. All right. And then overall, well, if you pretty much start at 72 and you stay at 72 the entire time through heating and cooling, there is no net change. You started at 72, ended at 72, net change is 0. That's ideal for a hot climate. Net temperature change is 0. So you're trying to minimize your net temperature change, trying to make it as small as possible, as close to 0 as possible. Minimize heating, maximize cooling, minimize net. Cold climate people, it's kind of the opposite. Imagine you're in the Arctic. I'm in the Arctic Circle. It's about survival, people. And your house starts at 72. Somehow it's 72 degrees in the Arctic. During heating, you want to gain as much heat as possible. You want to, okay, you want to maximize your heating temperature change. You want to get toasty. You want to get toasty. You want to get warm. Welcome to Breakfast Toasties. Shout out to my homeroom people. Somebody at my door. And then during cooling, say if you're in the Arctic Circle, you gain all this heat and the lights go out. It's nighttime. Do you want to lose all that heat? Do you want to freeze through the night? No. You want to keep all of that heat that you gained. All right. So during cooling, once you enter in cooling, you want it to flatline. All right. So there's no cooling temperature change. You maintain your temperature that you gained during heating. So you're trying to minimize cooling temperature change. All right. If you do those two things in a cold climate, if you do those two things, if you maximize heating and minimize cooling, look at the net. By the end of it, the net temperature change is massive. Okay, that's the goal. You're trying to maximize your net temperature change. Cold climate, you want to finish the whole test of the home, heating and cooling, you want to finish with the highest temperature possible. Hot climates, you're the opposite. You want to finish with the lowest temperature possible. Which house performed better? to look at your delta T's, people, in order to form conclusions. Remember, science is about evidence-based conclusions. Which house performed better, small or large, for each phase of testing, heating, cooling, net? Hot climate. Remember, we're trying to minimize heating, so we're looking for the home with a lower heating temperature change. The small home went up 6. The large home went up only 3. Okay, well, what house would you rather be in if you're in a hot climate in the desert? Would you rather be in the house that heats up more or the one that heats up less? The home that heats up less, the large homes. How do we know? Well, we looked at the delta T's, the temperature changes. You can't just say, like, Mr. Phillips, the large home did better, okay, in heating, all right? Just leave me alone. I want to be in my room listening to punk rock because I'm a teenager. Anyway, no, it doesn't work. That's not good science. Evidence-based, data-based, evidence-based conclusions, people. Because you compared the delta T's. Cooling. Technically, the small home did a better job there. It lost more heat. It lost 5 degrees, and the large home lost only 1. Small home did better there. Net temperature change. In a hot climate, remember, your goal net is to minimize it in a hot climate. Okay, ideally, you want a net temperature. The best net temperature change you can have in a hot climate is 0. So which house got closer to that? Which house heated up less overall? The small home went up overall by only 1 degree, and the large home went up by 2. Did you guys hear that? Cold climate, during heating, your goal is to maximize it. So you're looking for the house with a higher delta TH. Which house gained more heat? Because that's what you want if you're living in the Arctic. Well, the small home gained more heat. It gained 6 degrees Fahrenheit, whereas the large home gained only 3. Cooling. The house that lost less heat is the house that did better during cooling. The large home lost only 1 degree, whereas the small home lost 5. So in this case, in a cold climate, the large home did better. Overall, remember, in a cold climate, you want to maximize heating, minimize cooling, all right, and gain as much heat by the end of it as possible. You want as high a delta T net as possible. So which house had a higher delta T net? The large home went up by the end of things, when all is said and done, went up by 2. The small home went up gained only 1 degree in the whole test. So the winner is large home. Use your delta T's, people. Use them as evidence. That's what science is. Okay, the process of answering questions with data, evidence-based solutions. It's a wrap.